Given triangle ABC, with vertices, A, -1 7, B, 8 4, and C, 7 1. We are required to show that the triangle is right-angled. Determine the area of the triangle. And determine the equation of the circle passing through A, B, and C. As with all analytical geometry problems, it is a good idea to sketch a diagram, to better conceptualize and visualize the problem. It should be clear to see from the diagram that angle ABC is the only interior angle of the triangle that could possibly be 90 degrees. If you do not draw an accurate diagram, you will waste a lot of time in an exam performing unnecessary calculations. To show that angle ABC is a right angle, we will first determine the gradient of AB, and the gradient of BC, and then show that the product of these gradients equals -1. The gradient of AB equals -1/3, and the gradient of BC equals 3. The product of these two gradients equals -1, so we can now state that AB is perpendicular to BC, and therefore triangle ABC is right-angled. The area of a right-angled triangle equals a half the base times the perpendicular height. The area of triangle ABC therefore equals a half AB times BC. Before we can determine the area of the triangle, we first need to calculate the length of AB and BC, using the distance formula. The length of AB is, in simplest surd form, 3√10. Similarly, the length of BC equals √10 units. Now that we know the length of AB and BC, we can determine the area of triangle ABC, which equals 15 square units. Finally, to determine the equation of the circle passing through points A, B, and C, we need to know the center of the circle, as well as the length of the radius. Looking at the diagram, and in particular, the fact that triangle ABC is right-angled, we can deduce that AC is the diameter of the circle, since the angle subtended by chord AC, at the circumference of the circle, is a right angle. So, to determine the center of the circle, we will determine the midpoint of chord AC. The midpoint of AC, and therefore the center of the circle, is the point, M, 3 4. To determine the length of the radius of the circle, we will first determine the length of the diameter AC, and then half the result. Using the distance formula, the length of AC is 10 units, which means the radius of the circle is 5 units in length. Note that since ABC is a right-angled triangle, we could have also used Pythagoras' theorem to determine the length of AC. And now that we know the center and radius of the circle, we can determine the equation of the circle passing through A, B, and C. The equation of the circle, in standard form, is given by x squared plus y squared, minus 6x minus 8y, equals 0. For more videos like this, hit the subscribe button in the bottom right corner of your screen. Thanks for watching.